Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, CME Computer and IT Solutions.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 2 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Thank you so much for being here. And Jeff's got some cybersecurity news for you.
Yep.
Am I sharing?
Yeah, sure. Just this article on how botnets are basically taking over they call it the internet highway, but you understand what they're saying.
More of them than there are of us.
51% of traffic is done by bots. Wow. Now, not all of them are bad. I don't think that they're great, but they're not bad. Search engine crawlers, the search engines are always crawling websites so that they can link to them and stuff. And if you have a website, you pretty much want that, unless you've got super secret stuff, in which case, what the hell are you doing putting it on a website?
Yes.
But so there's a number of bots out there. There's also the bad bots, the malicious bots, which typically take over routers and other IoT devices or Internet of Things devices, which is why I don't like IoT devices. But
too easy to hack.
Yeah, and a lot of them are really stupid. They put, baked in passwords and stuff like that, which is great as long as those passwords are secret. But as soon as someone finds out, everyone finds out. And so, just so that you're not part of the problem, make sure your router or IoT device, if you can, update the firmware whenever you can, whenever a new one comes out, because those close holes that the bad guys are using to essentially take over your device and use it for attacking other people, either sending out spam, doing denial of service attacks, whatever it is. And sometimes they just reroute attacks so that they can't be traced back. So they're just running a single attack through it to a single site, but then they come back and see your device doing it, not the bad guys. Now you're not likely to get in trouble because it's really known that this happens, but still, why help them? So update the firmware. Now, I'd mentioned a few weeks ago that there were a number of routers out there that are no longer under support. I would recommend replacing those because you can't update the firmware on them because there is no updated firmware, and they are being actively used in attacks. And plus, they're slower than what you can get nowadays. So,
so rule number 1, no clicky. Rule number 2, updates.
Yep. Yeah. So,
good. Okay.
Yeah. And speaking of updates, Windows 10 is coming to end of life. No more security updates past October 14th. So, be aware. Do something about it if you
have questions. We have a computer expert right here from anywhere in the world. He can talk to you about what you've got. Can you update it? Do you need to replace it? There's a few options. I think we just posted something about that on the Facebook page.
Yeah. And this botnet article is actually from here.
There it is.
It's from, look at where it is.
Yeah, CME Computer and IT Solutions.
Yep.
Awesome.
So if you are wondering who to call, there's the phone number, and you can always just look for CME IT. And I'll put this article in the chat too, just so that you can find it.
Cool picture, huh?
Yep. I've got more articles coming out that some of them are even better. So next week I'll see if I can get 1 or 2 more to share with you guys.
Okay.
Awesome.
And we got some comments, so go ahead.
Okay.
Oh, hello. We've got Jamie and Scott and Cliff. Thanks for joining us.
So, hi, Janie.
Happy Friday.
From Long Beach. Yep. Yeah. Happy beginning of Memorial Day, too.
Yeah.
Scott.
Hey, Scott.
And Cliff. Hi,
All
Cliff.
Right.
And that's what we've got so far.
Okay.
The rest are my post.
All right. So you want to go with this part?
Oh, sure. So tonight we're looking at Galaxy Zoo JWST version. We'll be back in 8.3 seconds. There's a link to that book in the description. See, I said it right.
You know what? I see Roger's here. Do you want to? Should we have Roger? Next week's guest is actually here with us right now. Should we give him a minute of our time to say hello and say a couple words to you folks? I think it's good. There's Roger.
Holy cow! I could obviously use some help with
You're very
computer and
neon.
things. I'm like an ethereal character with different colors and whatnot. But
well, we're going to talk to you tomorrow, and we can actually talk about that kind of thing. Oh, you know
yeah. What? Okay. The quick thing is that to say about it is that we actually have launches efficient enough to actually have industry in space. If we're going to do that, I called it a redo of the Silk Road, which was trade that went between Asia and Europe and Africa for more than 1,000 years. So the same thing, only it's like you really have to do it. The bottom line is the bottom line, and all the things to make it happen, like, has to be along the equatorial area. That is the way to go. And
the
once
new
you do
Silk
it,
Road. Okay.
you've got to build things in space. I thought I'd give about 3 of them, and then people can think about. There's really, in the background, I've got about another dozen of things to make things going. Yes, you've got to have Sanford and Sons pulling, instead of that stuff you sent into orbit for $500 a pound, you're going to keep it there. If nothing else, you crunch it out, and that'll protect your people from radiation. Got to grow some food. Hey, you really, really want to have a fabrication center where you can put things together. You don't have to do origami, unfolding, and then once you throw the fairing off, the fairing gets stuck, and $500 spacecraft is junk. You put it together in a shop, then shove it out the door, and it goes on its way. Maybe one more. How about having the tow truck service? Think of Halloran Hill going to Las Vegas. Got to come out and get things. Some days the JWST is going to have some repairs needed. The tug goes out, gets it, pulls it back to the fab shop. They put the repairs on it. Maybe new batteries, maybe new power center, shoves it out the door. Tug takes it back up to its really inconvenient place way up in, I think it's Lagrange 1, a million miles outside of Earth's orbit. You can do so many things, but you've got to set up fabrication in orbit. Then you can become a space-faring nation.
Yeah,
and
good stuff.
I better not go anymore. I might be taking up your time.
We got a couple of comments. Stick around just a second, and then we'll be sure to bring you back next week for a full-blown show. There's Dawn. Hey, Dawn. Oh, and Janie says hi, Roger.
Oh yeah, Janie.
We'll cover more of that next week. Yeah.
Yeah, we'll have you on next week. We're going to talk about your lighting. I can see it's an issue. And then we'll have you on next week. And it sounds like we're going to be able to have you on again later if you've got a whole bunch of things and you want to talk about just 3 next week. Sound good?
Yeah.
All right. Thank you for being here, Roger. Really appreciate that.
Okay, I'll go backstage again.
All righty. Bye-bye.
And then we have Rob saying
greetings. Oh, hey, Rob. Welcome. Have we seen Rob before? Are you new here, Rob? That's great. Thank you very much. Yeah. Let's see. Where are you? Here?
Yeah.
Here.
So tonight's episode, according to the Zooniverse page, many different scientists are using NASA's latest space telescope, JWST, to image galaxies so far away that they are back at the earliest time galaxies appear in the universe. In fact, Anton just had an article on that where he JWST beat its own record before Anton could finish his video on the record that they made.
Was that actually from tonight or yesterday or something?
Well, we saw it tonight.
We saw it tonight, but
it was probably yesterday.
It might have been from yesterday. Yeah, so kind of timely.
Yeah.
Newbie, yay! All right, welcome.
Welcome. Okay, so Tuesday, also from Zooniverse, Tuesday, 29th, April 2025. We are thrilled to announce the launch of the Galaxy Zoo JWST project with hundreds of thousands of galaxy images from the Cosmos Webb survey taken with the James Webb Space Telescope. Cosmos Webb is the largest largest of the extragalactic surveys approved on JWST. We'll continue to work in the team and add more images from other JWST surveys and try to meet our goal to work with you to classify all of the distant galaxies imaged by JWST in a consistent way. And for this new phase of Galaxy Zoo, we're joining the NASA citizen science family. Everyone is welcome to classify, no citizenship needed. And you know, this is kind of special to me because Galaxy Zoo was my first citizen science project before it became part of Zooniverse. So I was very interested.
Like the earliest days, right?
Yeah. Well, okay, I did SETI at home, but it started cooking my computer, so I couldn't do that anymore.
I didn't know that.
Yeah. So, you know, so Pam, what can you tell us about this Zooniverse project?
Well, I'm going to go ahead and launch right in because this is a pretty interesting project. I think there's plenty here to sink your teeth into. And there's that April 29th relaunched. They've had about, well, it depends on how you count them, I guess, somewhere between 8 and 15 sort of phases of Galaxy Zoo. So this is the current page for Galaxy Zoo. And they've got they've got a little drama here. If you have witnessed what you're about to see, I suppose it's true, because these are new, items to classify from the James Webb Space Telescope. They have 2 segments to it, which I'm going to go into in 2 different tabs above here, just a little bit. Then, of course, they have all the nice little pictures they show you. 23 people are talking about this. You can join in too. We've been watching as this actually increments up pretty slowly. I think a week ago was 18%.
Well, when we first saw it, it was 17. Then when we were starting to put together this show, it was 18%.
And so now it's 21% complete. It's not going real fast, but I think if you want to participate in this particular project, you're going to want to go soon. It will, they have 129,038 volunteers, and they're probably the ones that are registered, right?
Mm-hmm.
I do these things and I've never registered, but they do have quite a few items to classify, and they've gone through a small portion of, what's up, 10%? Mm-hmm. Not quite 10%. Oh, no, here it is, completed. Well, that's fine. That's interesting. Oh, 948,000 classifications of 91,000 subjects, and 19,000 are completed.
Which
okay, that's how that works.
At least 10 people on each image.
Right. Yeah. Okay, so you want to try these out. Don't get too nervous about being right, because a lot of people are looking at every single subject. A little bit of information about it, which is what Jeff just kind of read. I think, this part here. We kind of like to pull these from these because it is very interesting. And there's typically...
And they usually know more about their project than we do.
Yes. There's typically other links. I actually have this one up, these 2 up. I haven't seen this one. Oh, that's the Facebook page profile. But you're welcome to look at those. We definitely leave plenty for you to do too. So I am going to go to the first of those 2. Let's see, what was it called? JWST. This is the Cosmos Webb subjects, and then the other one is from this CEERS version 5.
0.5.
Oh, yeah, 0.5, sorry. So we'll see both of these. I've got them in 2 different tabs. Yeah.
The version 0.5, to me, makes it sound like they're not quite done with it.
Oh.
That you're you're in testing, because usually version 1 is the first full version.
And
now they might not be using programming versioning, but that's
well, I
how
can
it is in
totally
programming.
believe that too, because they're constantly adding to this. So this may actually change from 21% complete to, it'll pop down again.
Yes,
And
they
we've
add
seen
more images.
Right, we've seen that happen with some other ones too. All right, so I'll go over to the Cosmos one first, and then I'll hit the Sears one next. The one outstanding thing I've noticed about this particular tutorial is they don't actually tell you how to do this, but there's some interesting information here. I think you want to read this and understand what they're about. They don't have a whole lot of these pages this time. Yeah, there's a series of questions. That's true. But like I said, they don't quite tell you how to do this.
Some are better at this than others.
Yes.
And this one, I think they assume you've already done other Galaxy Zoo projects.
Quite possibly. But they do give you a clue, and I'll tell you about that just in the next couple of dots here. Yeah, the thing that you're classifying is always going to be near the center. That's kind of important there. Then you can actually see them in two different respects. They talk about two main color versions, but they're kind of a couple of different things too. So, and you can flip them around. I think that's like, if they're dark, you can go light, that kind of thing. So there are some typical tools that we have seen before. And then I think this is where they give you the clue. Nope, maybe it's back one. Let's go back one. Because they talk about...
Yeah, you need to scroll a little bit there.
Let's see. No, they don't actually say it here. Where is it? Somewhere here. They give you a clue, because that's how I found out where to actually figure out how to do this. You want to go and you want to look at, need some help with this task. So to me, this is sort of after the fact. The tutorial typically, I think, gives you the how to do this. But in this case, the need some help with this task is the part where you go to look. And, kind of a typical screen. We've seen a couple different ones. This one happens to have these two different ones, as well as you can see it both positive and negative for both of them. But I'm going to go ahead and show you this need some help with this task, because I think this is where the tutorial should be. The tutorial should have been this, I think. Mm-hmm. So the aim here is to divide featureless galaxies from all the rest. And you want to consider the one that's in the center of the image only. If there's other stuff, don't worry about it so much. We got to... Oh, hey, Naomi.
Hi, Naomi.
Welcome. Glad you're here. So, they talk about, you'll see some things that might not be a galaxy at all. Maybe it's a satellite that's gone through the image, that kind of thing. But in general, we've got smooth. These kind of don't really have many...
They don't have features.
No real features like galactic arms. And really, this was very helpful to me, because I was kind of doing the tutorial and trying the tasks, and I just didn't get it. So I looked at the tutorial again, and I'm like, oh, let's go look at this part. And so you can see some really good examples of that. The next type is a disk with features. And that's not really a smooth thing. It may have these galactic arms. In fact, I think all these are going to be showing that, but some kind of features. That's the idea there. Mm-hmm. There are examples of the common features, but there may be something else interesting. They might have spiral arms. They could have a bulge, or I guess a bar.
Yeah.
Right.
No, a bulge you could actually see if it's edge on too. Because you would see the bulge in the middle.
Right. You're very familiar with this. Now look at that bar. That's beautiful. Or any other interesting features. These don't quite have galactic arms, but they're kind of like rings. I think that looks more smooth to me, but...
Well, there's something hanging off the bottom of it, but that could be something behind it, so we don't know.
Okay. Anyway, we've got some other things that aren't really what we're looking at. They call it star artifact or bad zoom. And you only want to choose this particular button on the task if it's not a galaxy. It's either a star or an artifact, or the galaxy is too far or too large, too small. It's just not these nice centered galaxy pictures. Sometimes the ones that are kind of big, you still can classify. Like I would say you can still classify that one. But yeah, if they're just like, wait, what the heck is this? And they're just, look at that. There's a big.
Well, that middle one you could probably classify.
Yeah,
You just ignore the streaks from the nearby star.
Yeah, they still wanted you to pick it as a, well, let's see, even though, for example, these are all classifiable. Oh, okay, these are classifiable even though there is a star artifact. So this isn't what we're talking about.
Oh, so these are all ones that you can classify.
Yeah,
even if
these ones
noise.
You could still work with, because you can get the basics of the galaxy in the center of the image. Yeah, even though there's this big bright star with all that's an artifact of the camera. You can still actually work with these. However,
there's a half image there.
This one?
Yeah, that's kinda, but you can still see enough to classify it.
Right. However, when it gets to stuff like this down here,
well, a lot of those, it looks like they mistook a star for a galaxy.
Well, or it's blown out. Maybe there's a galaxy in there somewhere, but
yeah,
you're not going to be able to tell, and you're not going to be able to tell anything about it. Yeah, look at this one. This is not. It's a bad zoom, I would call it. So anything like this here below, you're going to give it the star artifact or bad zoom button.
And basically, when you point out something like that, that means that they'll look at it and see what's wrong with it. Yeah,
that makes sense. And so like something like this, you can't, I mean, sure, there's a galaxy in there, but you can't really see the whole thing.
Well, I don't think you're seeing the whole thing. I think you're seeing part of a galaxy there.
Yeah.
And probably part of a relatively nearby one.
Yeah, I don't think I read this one, but this many galaxies can sometimes confuse the software used to focus on each individual galaxy to create the images you see, resulting in images that are too zoomed in or too zoomed out. I think they still want you to click it as a bad zoom. They would consider these a bad zoom. You just don't get a nice galaxy in the center here, or there, or there. It's just too far. It's too small, too far away, too dim.
And the upper middle just has a bunch of different galaxies.
Yeah.
So it's hard to tell which one is which.
Yeah, what's our target here?
Right.
We don't really have something in the center. And stuff like this.
Oh.
I would say
that's a satellite.
Yep. I would say you could still classify that one, though. I'm not sure about that. It almost looks like it's a star.
Right.
And then there's some weird things. So again, don't worry about it too much. If you think it's just a bad thing, just mark it bad.
Right. Because data can glitch.
Yeah.
Either on the chip or in transmission.
Okay. So some of these are nebulas or star-forming clouds. What do they say about that? I think this is probably still under this whole, click on it when a star artifact or bad zoom. These are the types of things they're talking about. Even down here, like these.
Oh yeah,
not
back to the
quite.
bottom line there.
Oh, pretty, but they're not galaxies. Yes, okay. But you can actually talk about them with people.
Yeah.
There you go.
Yeah, because if you point it out, they might not know that there's a nebula there, so you can point it out and they'll see it.
Yeah. All right. So one of the things I want to point out to you is each of these buttons has kind of its own path once you click on it. So you'll see that this one opens up quite a few screens like this that you can select from. Like I said, it's a pretty nice project. You can really sink your teeth into it. But let's go ahead and start to talk about the thing in front of us that we're going to classify. And I would say this is probably going to fall into the smooth category. Well, we kind of have some features here.
Yeah.
Kind of. I don't know.
Go reverse on that. Let's see if we can.
Yeah. Yeah, see, this one doesn't seem to have the kind of features that I feel like we kind of see in here.
Right, yeah.
And this is very pixelated. So, again, if you think it's smooth, and I'm going to go with smooth, I think, mostly so that you get to see the path it follows after you click on smooth. And with any luck, we'll see.
I think it probably could be classified as smooth because any variation could be random pixels that
Yeah, I think so too. But what I'm hoping is that we can see all three categories of smooth, features or discs, or star artifact or bad zoom, and all the different things that follow each one of these. I did get to see them when I was testing this out for you.
Okay, yeah, because when I was watching you do it, I don't think I ever saw a star artifact or bad zoom, but
I did a bunch of this later too. So, all right, so let's go ahead with smooth, and we'll click on the next at the bottom here. Now we get a whole bunch of other choices, like is this merging, or has a major disturbance, or a minor disturbance, or is it none? I think this is probably none.
Nothing.
We don't see two kind of cores like the merging one. You could argue maybe there's some minor disturbance there, but I think you're going to notice more when there is this either merging, major disturbance, minor disturbance. So let's go ahead and say none for this particular one. Again, you go with next, and a couple of these you can actually go back for now. And then maybe there's something else going on here. Ring, lens or arc, irregular. Oh, I just realized I never did go into the field guide because it is ginormous. There's so much stuff there. So
yeah, you know what? If nothing else, go on here to read the field guide because there's a lot of info in there.
I didn't go through everything there, but I think what you need is good enough here, at least the stuff I've seen so far. So if you do see something that's like, I don't know, you've got the field guide and it has plenty more. And of course, it's like a nice project where you can, in fact, delve deeper into the kind of work that you might be really interested in, and the field guide's perfect for that. Just you want a rabbit hole, you got plenty to work with. So we've got ring, lens or arc, irregular, dust lane, overlapping, central diffraction spikes, diffractions. You kind of can't see it, but I have a feeling it's kind of like a splay.
Yeah, kind of like when you're shooting on a star.
Yeah. Something else, which I actually did find a couple of those, and then nothing unusual. So
that gets them to look at it.
I bet it would. Yeah. So yeah, this citizen science project is a really great place for them to start with a huge body of data, so that they can get to the reports of what you found here a little bit faster.
Yeah. Well, like the first Zooniverse project, they were thinking 3 to 5 years to classify everything, and it was done in less than a year.
Yeah, like 175 days, like super fast. Which is a great use of because people feel like they can participate in something. There's some of these that give you naming rights. There's all kinds of good reasons to do this. You're bored, you want to do something, or you want to learn something. Again, all these things with field guide and all the links.
Yeah, this one has a really good field guide. Not all of them do.
No.
This one doesn't have a great tutorial, but it has a really good field guide.
Well, I think the tutorial got found in the part that says need some help with this task. Right. But I don't think we've got anything unusual in this particular object. So I'll go ahead with nothing unusual. And that's it. I'm done. So that's the path for that particular item. Oh, now see, I think we've got a couple of things in here. So yay. Now, I don't know if I'd call it...
I think it's still smooth.
Yeah, I don't know if I'd call it the features or discs.
But I think it's definitely merging.
Yeah, okay, so we're going to go with smooth again, right?
Yep.
Go ahead and click on next. Yep, I'm thinking this is a merging thing.
Right, yeah.
Yeah, I see two definite kind of cores. All right, so let's go ahead with merging. Next. Again, anything unusual?
No ring, no. I wouldn't even call it irregular because it's just basically two cores. Just like overlapping.
No, I don't think it's overlapping.
Yeah.
But you know what? Let's take a look at the guide here for this. Do we have it? We must have an overlapping. They've got every other thing in here. Well, okay. I don't see it. Do you? Tiny. All right, so they got to add one. One more. All right, so I would say definitely you can ask. You can ask. Well, I guess done and talk might be the place to do that in this one.
So you have to check you have to pick something before you can do Donatello.
Yeah. I would say this doesn't have anything unusual.
Right. Yeah.
Right?
Yeah.
All right. We have a consensus. Let's click that one and go ahead and see what our next one is. I think we got another smooth one. But let's just take a look at all the different pieces here. Well, we got some stuff hanging off of here.
Yeah.
Yeah, I got a little bit of, I don't know what.
Well, it looks like something that's been in an interaction because it looks like it's.
But this one doesn't.
Potato chipped, yeah.
It doesn't even seem like it's the same.
Yeah, well, right up there in the upper.
Here?
Upper right, yeah. It looks like it's kind of an S shape almost.
Yeah. But I still think it's smooth. All right, next. And do we think merging or maybe a minor disturbance?
Yeah.
Maybe?
Yeah.
All right, go ahead with next again. Again, we see these any regular things. Rare features, I guess it's called. Sorry, rare features. I don't think there's anything that's...
Dust lane maybe, but...
Oh, you think maybe a dust lane?
Maybe. Take a look. No, maybe not.
I wouldn't say there's a dust. If anything, is something hanging off the end there.
Right, yeah. No.
No, I still don't think we have nothing unusual. So there we go with that one. And that one's done. Give us something good. Oh, look at this.
Oh, there's actual spiral there.
I think we definitely have features or discs.
Yep.
Right?
Yep.
All right, so now we get to see this process. Could this disc be viewed edge on? No, I don't think it is.
Yep.
They give you little examples like what my edge on might look like. That's the bulge there Jeff was talking about.
Mm-hmm.
Nope, I think we've got something else. No bar, weak bar, strong bar. I'm going with no bar.
Yeah, I don't see a bar.
Is there a bar feature through the center of the galaxy? No, not for this one. Go ahead with next. So you can see there's some different aspects to this path than there were for the smooth one. Is there any sign of a spiral arm pattern? Yep. Absolutely.
Yep.
Absolutely. Oh, these are much harder to tell. Isn't that interesting? We didn't even look at this one before. But that's definitely, so beautiful. So yeah. And I think that, nope. One more, I guess. How tightly wound do the spiral arms appear? Tight, medium, or loose?
Tight.
Tight.
It's almost a disc with how tight they are.
Okay, I'll get one more. Do we have 1 or 2, 3 or 4 or more than 4 spiral arms to this galaxy? There's at least...
I see 3.
At least 3.
There's at least 3.
Do we want to pick 3 or do we want to say... I think, let's pick 3. Let's pick 3. I think we're good there. And again, there's going to be a lot of people that are going to cover these. So I think if there's discrepancies, they'll probably call it out. But if everybody kind of has the same idea, I think they'll take it as, that's probably what this is.
I think in the first one, if there were enough discrepancies, they'd keep it on there for more people to classify.
That makes perfect sense. All right, is there a central bulge? If so, how large is it compared with the galaxy? I think there is with this really dark spot there.
Yep.
Yeah, these are really just too hard to tell, I think. But I'm going to go,
I think a large or moderate.
It's not small. It's not none.
Right.
Large.
No, not quite large.
Dominant takes up, I would say, more than 50%.
Yeah, and the large looks like it takes up half of it.
Yeah.
So moderate, yeah.
Let's go with moderate. I think that's a good pick. All right. Are there
Still not done.
No, this has quite a lengthy path. Yeah. Are there any obvious bright clumps? I have seen some. I would say this one does not have any obvious bright clumps. Yeah. So no. And now, is this one merging or disturbed?
I don't see.
I don't think so. No, it looks like a pretty nice regular old spiral galaxy. Regular old. All right, and we've got any rare features: ring, lens, or arc. Irregular dust lane, overlapping, central diffraction spikes, something else. No, I don't think there's anything unusual about this particular galaxy. Again, we're looking at the center one. There's something up here, but that's not our target. Yeah. Nothing unusual. And now we're done. Of course, you could go done and talk if you have questions. All right. Let's see if we can get a star artifact going. I would say this one's smooth, but let's take a look. Yeah, I'd say this is pretty smooth. It kind of just looks like a
potato.
I'm not even sure it's a galaxy, but I guess galaxies can look, whoops, went too far, can look like this kind of clump of stars, not necessarily a galaxy looking thing. I don't think we have any disturbance. Let's just, no, I don't think we do. None. Sometimes it's easier to see them with the
what
light.
is the 4-way show?
Oh, this one?
Yeah. Not much.
No. Yeah, I don't think there's disturbance there. All right, and so now we're into the any of these rare features: ring, lens or arc, irregular, dust lane, overlapping. No, I can't see anything like that.
No.
Not even something else. I have seen something else in some of these, and that's that. That one's done.
Yeah, the one with the smiley face.
What? What you talking about, Maynard? This is not just a smooth.
Yeah, it looks like a.
We got a couple things going on.
Yeah, it looks like a clump there.
Let's see. Features or discs? Disc, right?
Yeah.
I don't think it's a.
It is edge on.
Oh, you think it is?
Yeah.
Oh. Okay. Well, again, somebody else will pick it up if we don't get it right. Rounded, boxy, no bulge, rounded.
Yeah.
So here we go again. There's some different things to pick once you clicked on that other one.
It's interesting that there would be one that's boxy.
I have seen it.
Oh, okay.
But this is more rounded. Any obvious bright clumps? Yeah, yes. I would say so.
Yep. Right
kind of here and there.
Well, the one is the central bulge, but there you can see a bright clump.
Yeah, there's a clump there. And they kind of give you an example of it. All right, merging, major disturbance, minor disturbance. Maybe minor disturbance?
Doesn't really, aside from the clump, let's see the 4-way. Because I thought there was something that I saw there. Yeah, it just kind of looks like the disc above and below.
Yeah, just do your best. Just do your best. What do you think, minor?
Okay.
Any rare features? Ring, lens or arc, irregular? I don't think so.
No.
And now we're done. Give us something good. Ooh, this kind of seems promising. That's a little strange.
Let's see the 4-way.
So, okay. Yeah, I would say there's features or discs, right? And then, probably edge on, right? Let's go rounded. Box is kind of boxy. It's not real rounded.
That's true.
It's more oval than rounded, but I don't know. Let's try boxy because
let's look at the 2-way. Let's see.
Oh yes, okay. Yeah, that's a little more boxy than than some of the other ones. All right, so now we may see some new stuff this way too. Oh, okay. Kind of the same things. Any bright clumps? I don't think so.
No, but I think I see dust lanes. But
that's possible. Merging, major disturbance, minor disturbance.
There's some kind of disturbance there.
You think minor, major, or do you think it's a merging?
Let's look at minor to me.
Minor, okay. And any rare features? Where would you see dust lane in this? I don't really see that.
I guess a dust lane would be something that covers up part of it. Well, like maybe in this upper one.
Oh, I see what you're saying there. Well, let's just see what we got.
Oh, let's see how it looks in regular light.
You mean this?
Yeah.
I don't know.
Yeah, hard to tell.
They're both kind of cut off there, aren't they? Well, let's say dust lane. And let's see what happens. Oh, we're done. We're done. All right. We got a smooth one again, I think.
Yeah. Well, did you have another one that you wanted to go through?
Yeah, we've got another one. I was hoping we'd see a star artifact or a bad zoom because that is kind of interesting. And again, it does have its own path after you pick, but I'm going to go slow. Let's see if we can get through this real quick and find one. Nope, I don't think we got a merger. I don't think we got anything weird. Nope. And after a while, you kind of get a little better at it too. So, ooh, this is different. But I don't know that it's a star artifact or bad zoom.
It looks like it's a merger to me.
Oh, there's a lot of stuff going on here.
Yeah.
All right. Features or disk. Not smooth, right?
Mm-hmm.
Not a star artifact. That's what's left. Edge on, probably.
Mm-hmm.
Probably edge on.
Yep.
With a bulge. I really like this version. They seem to have so much more detail.
Mm-hmm.
And even in color, sometimes it's... All right, edge on. Like that. Rounded, boxy.
Yeah,
rounded. Yes, I would say we have some bright clumps.
Yep.
Yeah, I think we got some merging.
Yep.
Maybe even like...
merging or... yeah. They're probably not done merging, yeah.
Yeah. We might have some rare features. Ring, lens or arc, irregular. Irregular. There's a lot of irregular there to me, but...
yeah.
What do you think?
Well, it looks like it's more covered by the fact that it's merging rather than...
oh, and you can do some of the normal things by zooming in. And I think you can...
rotate stuff.
Oh, yeah.
You have to zoom
That's
out
back
to
to
see.
normal.
Yeah.
That's back to normal. So, yeah, if you want to get closer to it, you can use this plus sign, which is a zoom.
Mm-hmm.
Again, it's a lot of the same things you see on a lot of the other Zooniverse projects.
Mm-hmm.
But let's see, what did we decide?
I don't think that there's anything else out there other than the fact that it's...
not a regular?
well, it's not just a weird clump of stars. It looks like it is a merger, but
Yeah.
you could call it irregular.
Yeah, it seems irregular to me. And done. Yep. All right. Well, I don't think we're going to get to a star artifact. I don't think we can move forward either to try and find one. Can we, or can we?
No.
No.
You could make a sloppy, picks, but then that just messes up their data.
I don't want to do that. I don't want to do that. All right. So we'll go on to the other one. And again, good stuff. Doesn't really tell you how to do this, but it is the Cosmic Evolution Early Research Science. So it's sort of a different set of images. Still the James Webb Space Telescope, but it's somebody else's project, the Sears project, unlike Cosmos Webb. So, we got a comment.
Oh, Don. If there is a dust lane, it should be dark. Yes, exactly.
Right.
Yeah.
So, you can certainly read through these yourself, but I just didn't think they gave you a whole lot of information. But there's some different pictures for this one. A series of questions again. Just take your best guess. Sometimes there's multiple galaxies, but we want the one in the central. Same thing. And here it is. Nope, that's not what I was thinking. Somewhere in there, I remember seeing where you really get the information.
It said press need help on this project. So.
Need some help. Yes. And it's basically the same sort of thing. I think I checked, and it was pretty much exactly the same. Yeah.
Just a different set of images. You're still checking.
There's very similar, the same images. They might be all of them the same images.
Right. No, I meant not in the field guide, but I meant that we're looking at here.
Oh, it is a little bit different because you've got, instead of that set of 4 and set of 2, you've got this one, and it's negative and positive of one image.
Oh,
so
okay.
the Sears group must be a little bit different than the James Webb Space Telescope was. So you can go back and forth, but this is wild.
So we're only looking at the central one.
Well, but I'm not even sure. This might be a star artifact or bad zoom.
Well, let's see. Is there a back button on here that you can go back if you pick one that you didn't?
Yeah.
So it's.
Yeah. See,
there's a back.
There's the back.
So if we find that.
In this case, though, we do get to see the new set of choices. What problem do you see with this image? Is in this case non-star artifact, bad image zoom. I almost think it's a bad image zoom.
I don't, because it doesn't look like there's a chopped off bit.
Well, but they didn't zoom in like this one or
Oh,
that one.
that's right. But sometimes when they say that
that
there's
one,
too many things, that it doesn't know which one's central.
Yeah, and I think if you really wanted to check this again,
yeah,
let's
go down
see.
to the bottom there.
Oh, that's funny. They have.
Oh.
Oh, I get it. It's tagged to this particular part of it. So,
so that's nice.
That's interesting. So yeah, is it a star? No.
Oh.
Yeah,
AC is here. AC,
Oh,
hi
hey,
AC. Wow, how many of these can you do before your eyes cross in the image?
Apparently 50,000. The one guy, when they first started this, he was like, I did 50,000 in one. I can't be a day. It must have been a week, right? And I thought I would go bananas. So yeah, I think, and it probably depends on who's doing it too. Some of us would have more tolerance than others. Yeah, bad zoom. Look, all this is a bad zoom. That's a bad zoom.
That looks more like what we're seeing here. Yeah.
All right, so I'm gonna go ahead with bad image zoom. Cool. All right. So let's see. Oh, this is a new one. Oh, but we got something in the center.
Yep.
Yay, and we can actually zoom into it. Looky there. It looks
smooth to me.
A little bit spiky though. But I wouldn't call it a disc.
No.
Yeah, I'm gonna go with smooth.
Oh. Hey, Daniel.
Hey, Daniel, welcome.
Is there any way to know the distance and heading from our sun for something that you are identifying? I would feel more invested if I knew. Well, okay,
that is a cool idea.
The patch of space that they're looking at is a very small patch. So,
well, the Cosmos Webb one, I don't know about the Sears.
Yeah, so the Cosmos Webb one is a very small patch. So, as far as the different galaxies in that patch, probably no way to really tell where, but I'm pretty sure you could find out where that patch is. Yeah,
the Cosmos Webb is very small. In fact, Anton mentioned that in the video we saw earlier today. Again, it was like today's or yesterday's. So I'm going to go with this. I'd say it's round. So yeah, we got a different screen. That was cool. Merging or disturbed? No.
I don't think so.
No. I didn't pick it. Okay. Irregular. I only say that because all the little spiky things off of it. I'm going to pick irregular.
Almost. Yeah, it's either irregular or diffraction spikes.
Oh, yes. I see what you're saying. Yeah, I don't know. Oh, I can pick two?
Two.
That's odd. I thought it was going to go back and forth, but nope. I'm going to go with diffraction spikes. Let's see what happens there. Oh, we're done. All right. I think you're getting the picture. And yeah, if you want to do any more, go to Galaxy Zoo. So I want to go through this part quick because it's kind of interesting. We do have, the classify part, but then you've got the research, the team, results, education, frequently asked questions. There's place to talk. It's sort of a forum thing. People collect these. And then there's this, and I actually have a tab for that. So we'll look at that in a minute. But they talk about this long-standing project for more than 15 years. They've been bringing these different sets of galaxy classification projects to you. Yeah, you can tell a lot about a galaxy just from its shape. A lot of people have come through here. But yeah, what they call secular process can make a difference too. Each large galaxy has at its heart a massive black hole. So tons of stuff here to read. I really like to have this kind of information on these projects. And then they talk about, live on the site now, Galaxy Zoo JWST. Many different teams of scientists are using NASA's latest space telescope. That's what Jeff read at the beginning. But here, as you see, Daniel, here is this section of the sky, and they've put the moon in here for comparison.
For size comparison, yeah.
Right. The moon would almost cover what the Cosmos Webb NIRCam footprint, 0.5 degrees, 5.4 degrees, has covered. So, yeah. And we can probably figure out direction and stuff. especially
have
if
to
you
look that up for Cosmos Web.
Yeah, and they might even have something at this NASA Citizen Science Family. See, there's a bunch of links you can also ISSI. Oh, there's the Sears project, but they don't actually give you a map of that one.
Where it is in the sky. Yeah.
Yeah, they might be maybe here. Let me look at that one real quick. This takes an extremely deep images of 100 square arc minutes of the sky, which is about even smaller, 1/8 the size of the full moon. So absolutely fun stuff. If you want to delve into that, you got a lot to work with. They talk about the team, and a lot of these people have come and gone. I don't think anybody is from the original group of people who did this.
Well, probably because the original people are all busy writing their papers.
Probably, or
which is a good thing. So each group gets to write their papers on it. Then a new project shows up.
Yeah, with new people, but it's a pretty big team.
Yeah, because this is not the second Galaxy Zoo project. There have been plenty.
Yeah, like I said, there's something like 8 to 15. We're not sure the numbers, and I didn't delve into it that much to see what the difference is. So here's a little bit about the Sears Cosmic Evolution Early Release Science Survey. All these things have a survey name, so there's that one. And at the very end of this row here, I'm going to let you look at the collect and talk if you want to, but there's this Galaxy Zoo link, and that goes over to here. I really think it's kind of fun that this project has been going and changing and evolving, and it has new data sets. That's kind of cool if you ask me. Past projects, finished projects, learn more, and I think somewhere in here there's
show the past
papers.
Projects just to show.
It says paused. Sorry,
paused.
I said it wrong. Paused. Oh, okay. So
there are some that are paused. They're not
finished. So all these are the Galaxy Zoo type. Oh, bar lengths. That's kind of neat. Yep. And I think somewhere in here they talked about the papers that have come out of this
That's probably in the about, but
yeah. We can go look at that. Well, that's where we are here. Oh, sorry. I did not finish this. We got the results. Oh, yeah, public classifications, publications. Here's the list of them. The story so far. Oh. Yep. Oh, another comment?
Yeah, AC says, it's very comforting that all this will make for a portion of the training data of an astronomy AI classifier.
I don't think he'll ever do as well as people can insofar as pattern recognition.
Right, yeah.
I could be wrong. I get that.
Well, here's the thing that the AI astronomy can really help with. Of all of the thousands of images, here are the 15 that that probably have something that you want to look at. Yeah. That's and the others can go into these buckets over here. And someone who
so you get to play with the really interesting stuff.
Right. And quite frankly, it puts everything in buckets so people who are like interested in that bucket can look at just those.
Yeah, that's a good way to look at it. So yeah, we've had the Galaxy Zoo one. It started back in July of 2007. Is that when you were doing that?
Mm-hmm.
Wow. Okay, I was thinking it might have been a little bit longer ago, but nope. That's about 15 years ago, isn't it? 150,000 people. I think it's in here. They talk about the 175 days or whatever that it took to finish this huge amount of data that they were thinking was going to take grad students probably years to accomplish.
Yeah, but grad students, i.e. slave labor.
Free, yeah. And then they talk about number 2 and Hubble, 4 or candles when we started to lose count. Okay. But good stuff here. UKIDSS.
You notice they stopped putting numbers on them. That's what he meant.
Yeah. So now we got different names. Desi, decals. Probably just, here it is. Dark Energy Camera Legacy Survey. They probably just started naming them after
after the project.
Yeah, after in this case, the survey or the camera or something. Oh, are these moving? That's kind of wild. Yeah, site began to include a new set of decals images from survey's second data release. So yeah, I mean, you can really kind of follow along with this whole story if you care to. Ferengi, okay. Gamma,
and it probably means something, but
yes.
they spend an awful lot of time figuring out the words to make an acronym that they like.
Oh, it's a code, the Ferengi code. So yeah, if this is float your boat, man, you can play and play and play to your heart's content.
Yeah.
Galaxy Zoo, Euclid, and we're not quite done. Yeah, related projects, mergers, published results. Here we go. Yeah, more publication. The publications page. This includes results from multiple phases of the project, including the original Galaxy Zoo. Good stuff. All right. And so this is where I'm at, right? This page here? No, I'm over here. This page here is just one of the two, because then they've got this blog, but then there's some statistics. See, they say it's 8 projects, and Wikipedia thinks it's 15. So, but they have a blog, and that's kind of nice. They don't seem to have too many. They're not posting daily.
Mm-hmm.
You've got this one from the announcement April 29th, and then this one, I don't know when this was published, but yeah, I mean, really, if you want to play this, oh, here you go, Daniel. Here's the Cosmos Webb image in the actual space, in the stars in space. That's still a darn lot of stuff. Yeah,
Well, they tell you the filters, but they don't actually give the coordinates, just how big it is.
It's probably in here somewhere.
That might be.
So yeah, Daniel, there you go. The blog. Look for it's blog.galaxy blog.galaxyzoo.org. And if you find out, let us know.
Yeah.
In Japanese. Oh, that's a neat picture. So, delve into it. Yeah, not a lot. January 9th, March 19th, 24th in Japanese, if you know Japanese. So it's not hugely, written to, but there's some good stuff in there.
Well, 2 or 3 a month is fairly decent.
But with as huge a team as they have,
right.
All right. So again, this is the Wikipedia, and they say there's been 15 versions.
Well, over there where they were giving the past versions, they also had a list of like 5 or 6 related projects. So this is probably, including the related projects.
They're just counting them all. Okay. Yeah. But yeah, I didn't really delve into this too much because I really wanted to demonstrate the project for you. But you can really read into this, the origins, and I think this is where they talk about the first set that he said he looked at 50,000 in one day and was like, ugh. Where is it? Is it here? Might have been him. No, I don't know. Somewhere in here, you'll see it. 50,000 in the first week or whatever. And yeah, I think they had a great idea. Here it is. The first Galaxy Zoo, more than 40 million classifications were made in approximately 175 days by more than 100,000 volunteers, providing an average of 38 classifications per galaxy.
That means that each person on average did 400 classifications.
Wow.
Actually, no, more, because they would have done multiple classifications of the same image. Oh, yeah, each person providing an average of 38 classifications per galaxy.
Yep. Right. So yeah, this is a really nice article about the original and the 8 to 14 total. Yep, retired projects, Galaxy Zoo 1, 2, mergers. So this is how they get the 15. Here's how you're going to see they get the 15. Supernova, Hubble. Wait, 4. That's we're into 6 now.
Well, yeah,
7.
because those are the ones that the other site considered related, not
Ah,
actually.
active. Oh, so radio galaxies. We've talked about that.
Mm-hmm.
Ongoing, completed, related, rotation. There's some really, really good stuff in here.
Mm-hmm.
Okay. Yeah. So more links, rabbit hole.
Mm-hmm.
Look at that. Oh, it's so beautiful. Galactic bars and bulges. Jeez. Yeah. Some of these people have probably put these in some of their collections. Oh, the mice galaxies. Yes. So on and on. References, all kinds of good stuff. That's what I have for this project tonight.
Mm-hmm.
Really appreciate you coming on and hanging out with us. Let's see. Where's our nose?
Okay.
Yeah, I think that if this is something you want to do, definitely don't dally too long because
Right.
it will eventually be completed as well.
Should last a while, but it won't be up there forever because it is completing about 1% a day from what I've been seeing. Ish. Maybe every couple days a percentage, but
yeah.
So it won't last forever, but it won't be gone tomorrow.
No. So if you do it by days, you've got approximately a month.
Yeah.
A little more than a month.
Unless they add more images.
Yeah, and they very well may.
Mm-hmm.
They very well. So go ahead with this part.
Okay. Some stellar events this week, May 23rd through May 30th. Oh, Janie says something.
Thanks for the demo and explanations of readings. Have a wonderful Memorial Weekend. Blessings to all. Thank you, Janie.
Yep.
You as well.
So, the current Globe at Night project continues through May 27th. Look for Leo or Bootes in the north, or Crux in the south. This is also a citizen science project where it helps you determine light pollution in locations all over the Earth, because you take a photo in the app and it'll then compare the light pollution in the sky as you're looking at that galaxy.
We got a couple of comments
from AC.
Just wait, when the Nancy Grace Roman Space Telescope is expected to downlink data at a rate of 250 to 500 maps.
Megabits.
Yeah, it's my eyes.
Megabits
resulting in a daily data volume of
11 terabits.
Is that the terabytes?
No, terabits.
Terabits. Okay.
Okay. So again, 1 and a bit terabytes.
Yeah. That what AC said.
What does he say?
This will be one heck of a Galaxy Zoo project.
Yeah.
You think the Galaxy Zoo people will get it?
Don't know.
I think that's a factor too. I don't know.
It depends on which
some
group.
team will probably want to have
some team. Yeah. And
something
maybe multiple projects, depending on. They'll probably have AI classify things into broad categories and then work those categories, or they do it into categories and have a bunch of, we don't know what this is from the AI, and so if there's only a few, they do them. If there's 100,000 or so, they'll probably create a project for it.
Yeah,
depends on whether it's faster to do them or faster to create the project.
It's probably faster to create the project. I think that's where you are right there, right?
May 23rd, Venus and the Moon are in conjunction, and Venus is 4 degrees south of the Moon. May 24th, Mercury and Uranus are in conjunction. And May 25th, Moon is at perigee. May 26th is the new moon. Don't know why they don't line up, but they don't. Not always. Sometimes they do. And Mercury and the Moon are in conjunction. Also, Uranus and the Moon are in conjunction. But wait, there's more. It's Memorial Day.
In the USA.
In the US, yeah. Probably equivalent to Remembrance Day in other nations.
I think you're right.
May 28th, the moon rides high. And Jupiter and the moon are in conjunction. May 29th, Mercury is at superior conjunction, which means that it's past the sun. We're looking at
beyond the sun from us, opposite. Yeah.
Which means that it might even be brighter because we're seeing more of the bounce back from the sun on it.
What?
Well, no, because if it's behind the sun, then we're seeing more of the surface of it.
We won't see Mercury at all behind the sun.
Well, if it's in conjunction, if it's nearby, if it's close enough, then then the sun will still be too bright to see it.
Oh, hey, John, have fun. I can't wait to start classifying. Thanks for a great overview.
Yep.
And thanks for the suggestion. That was Dawn's suggestion, and I think it's a great project. I really appreciate you telling us, go look. So, yay.
Yep. Okay, May 30th, Pollux is 2.3 degrees north of the moon. Also on May 30th is our Friday night show because it's a Friday. We have a guest. In fact, you just met him not too long ago. And so if you were here last week, you know who it is. And if you're here this week, you know who it is. So, so much for building tension in this. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel.
What inspires you the most for the coming week? So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live again, because next week we are going to have Roger back, and I'm going to just read a little bit of his bio to you. Roger Carlson earned a master's degree in studies of the future from the University of Houston, Clear Lake City Branch, Texas. The studies centered around the debates between the techno-optimists who predicted abundance and space commerce versus the pessimists who fretted about a new dark age caused by peak resources and the oncoming new ice age. So there you have it. Should we do a shout out?
Sure. Oh, I think the difference between the pessimists and the optimists is whether we actually get into space or not.
Oh, okay.
But,
all right.
So yeah, let's do their shout out.
John was here, and AC was here, and Janie Becker, yay. Daniel, thank you for being here. Also, Naomi and Rob. Rob's a newbie. We're glad you're here. We said Janie. I think Scott's here. Yep, there's Scott and Cliff. Cliff, you're awful quiet this time. Are you out observing?
Actually,
because
nope, here he is right here.
Oh, Anzac
we have
Day.
Anzac Day on the 25th of April and Remembrance on 11/11 every year. So.
Got it. We're so glad you're with us this week. You know what? It is always a better show when you're here because you contribute so much. You ask really fabulous questions. You give us suggestions like tonight's episode. We did that from Dawn's suggestion. It's always a better show because you're here with us. We really, really appreciate that. Yeah, we got one more, right?
Yeah, don't laugh too hard, AC. Antarctica's ice sheet is actually growing in the past couple of years.
Yes. Read about that.
Yep.
All right. Anything else from you?
Nope.
I'm good. We'll still continue to look for your comments. Thanks so much for being here, folks.
Yep.
Have a good night. We'll see you next week.
Yep.
Good night.